I wonder if we could get some of you in the back to open some of the doors to the outside and block them open some way in order that those of us located in the more favorable positions can be as comfortable as we may. I should like first to acknowledge the university's partners in this evening's lecture. The Frontiers of Science group has given generously, participated generously, both personally and financially. I should therefore like to ask those who are here as representatives of the Frontiers of Science group to stand in order that we may appropriately recognize them. Our speaker this evening will be introduced by his student and colleague, Dr. Jens Ruud Nielsen, Distinguished Professor of Physics at this university. Professor Nielsen.
I'm very happy to introduce our speaker tonight. I'm grateful to him that he will come to Oklahoma again. And I'm very happy to see such a large audience. I'm sorry that more would have liked to get here than have been able to get in. I shall not try to enumerate his many contributions to physics, for that would require a review of the history of physics since 1913, when he published his epoch-making theory of the hydrogen atom. More than any other physicist, he has guided and shaped atomic physics during these 44 years. His correspondence principle was a main guidepost in the development of quantum mechanics. His notion of complementarity provided a clue to the interpretation of this theory and gave us deep insight into the nature of human knowledge. And he will talk about some of these things tonight. Professor Bohr has wielded his dominating influence upon physics, not only by his own trailblazing contributions, but also through the unique Institute of Theoretical Physics, which he has created in Copenhagen. Physicists from all over the world have flocked to this institute to learn from him and to get his advice and criticism. When they have gone home, they have spread what has come to be called the Copenhagen spirit. As someone has said, Bohr has inspired more physicists to inspire more physicists than any other man. Yesterday I talked to a young Japanese chemist, and he told me that I'm a kind of great-grandchild of Niels Bohr. My major professor spent a year at Copenhagen. No physicist is more widely admired or better loved than he. As some of you know, this is his second visit to the University of Oklahoma. 20 years ago, he gave a lecture here on the problem of causality in atomic physics. After his arrival on the campus then, he told us that he really felt that he ought to give also a more technical talk. And so we arranged for another lecture, and he lectured on his drop theory of nuclear structure, which he had just then developed. This was a theory that he applied 2 years later to explain uranium fission. As all of you know, it was he who brought the news of fission to this country in 1939. After the war, he has devoted much effort to plead for international control of atomic energy and for measures such as free flow of ideas and information from country to country that can reduce world tension and ensure mankind against the devastation of nuclear war. For these efforts, he received the first Atoms for Peace Award a few weeks ago. I would like to hope that he will yet receive the greater reward of seeing his advice heeded by the statesmen of the world. Professor Bohr retired from his professorship 2 years ago and was succeeded by one of his 4 sons. But he continues to serve as director of the Institute of Theoretical Physics, and he works, I'm told, as hard as ever. He is chairman of the Danish Atomic Energy Commission, which has a remarkably ambitious program for a country less than 1/4 the size of Oklahoma. He is president of the Royal Danish Academy, chairman of the Danish Cancer Committee, and so on. And it may interest you to know that he is also president of the Danish counterpart of our own Frontiers of Science Foundation, this so-called Society for the Diffusion of Scientific Knowledge, founded 1824 by Hans Christian Ørsted, the discoverer of electromagnetism. Ladies and gentlemen, I'm very happy to present the pioneer of atomic physics, His Excellency Professor Niels Bohr.
Ladies and gentlemen, I am deeply moved by your warm welcome and by the kind words of my old friend and your distinguished physicist, Herr Jens Rud Nielsen. It is a great honor for me to speak to you at this great University of Oklahoma, where such vigorous and enthusiastic endeavors for education and scientific research is taking place. And it's a very great pleasure to me to have come back here after visit my wife and myself 20 years ago, for which we have very treasured remembrances, to come and see just how the old friends and see how the activities of this university are shaping and folding themselves. This morning I had the great pleasure of, in your physical department, to seeing the many-sided researches of, so to say, all part of atomic physics, which playing and are going to play very large importance for technology. Tonight I shall not try to tell you anything new about atomic physics, but with the theme for this lecture, atoms and human knowledge. I want just to describe how we, in this new field of experience, the exploration of the world of atoms, where we, so to say, wandered unknown land on paths hitherto untrod by men, we have got a very forceful reminder of our position as observer of that nature of which we are part ourselves. In order to just give you impression about what this new lesson has been, I want a few words to remind you about the development of the great edifice which hitherto has been the basis until the very latest years for all technology, and which we often refer to as classical physics. This has in itself been a great and truly human endeavor. It is not so that we in physics just record measurements and can just directly put them together by means of the notions with which we are prepared from orientation in daily life. But it has been through the years an endeavor to develop human concepts, views suited to order and comprehend the increasing experience. And everyone you know, then this task has been a long one. In Greece, in ancient Greece, where to the admiration of all later generations, such a spirited effort was made to base science on well-established, clearly pronounced logical principles. And where, you know, such a wonderful contributions to mathematics were made, has been the foundation for the later development. It was not found simple to liberate oneself from experiences like that of exertion by the movement of our bodies, or even of the motives for our actions to which these motions may serve. And it was first 2,000 years later, in the time of the Renaissance, that it was possible for Galilei to liberate himself and to renounce on explanations for motion itself, and just have to take, as you all know now, uniform motion as something elementary, and only ask for causes for changing of motions in terms of forces. Out of this, also all know, grew the edifice of classical mechanics, completed in such marvelous way by the genius of Newton. The description one arrived to was a so-called deterministic description. Meant that it proved possible on simple principles from the knowledge of the state of a physical system defined by the position motion of its part, by the knowledge of the forces between these parts, to calculate, to predict the state of the system at any later time. This great achievement, and first of all, of course, Newton's explanation of the Keplerian laws governing the motion of the planets around the sun and satellites around the planets, made an overwhelming impression at that time, and such description came to stand as the ideal for scientific explanation in all fields of knowledge. But what we have learned in the exploration of this new field is that we meet with phenomena which cannot be pictured such way which defy, as we would say, pictorial, deterministic description. The essential point was, starting point, was the discovery of an element of wholeness, so to say, in physical processes, going far beyond the old doctrine of the restricted divisibility of matter. This element called the universal quantum of action, which was discovered by Planck in the first year of this century and came to inaugurate a whole new epoch in physics and natural philosophy. We came to understand that the ordinary laws of physics, classical mechanics, and the laws of electrodynamics, which have equal importance, as I need not say, in technology, and for instance, the consequences was the creation of broadcast. That these laws were idealizations which can only be applied in the analysis of phenomena where the action involved in any stage of this analysis is so large compared to the quantum that it can be entirely neglected. This condition is amply fulfilled for experiments on ordinary scales. But in phenomena which depend on individual atoms, we meet with quite new physical laws. Now, what could one do? And this was, I can say at once, it proved possible by most active cooperation of, so to say, whole generation of experimental and theoretical physicists to get a generalization of the classical physics called quantum mechanics or quantum physics, which help us in expressing these laws. But this kind of expression is, in principle, a statistical one, and has gave rise to very much discussion whether we really were dealing with something which was an irrevocable step in the description of nature, or whether we have to do with some expediency which later have to give it up for again a deterministic description. This problem has been essentially, to my mind, fully clarified by a radical revision of the very foundation for the use of our most elementary physical concepts. We have to ask ourselves, how do we communicate physical experience at all? And it must be clear that even if we are quite beyond the scope of classical physics, then we can only speak about experience obtained under experimental conditions just described in the ordinary way. That's simply logical demand that by an experiment we must understand something about which we can tell others what we have done and what we have learned. That actually means, and that's what every physicist do, one couldn't do anything else, to use in the experimental arrangement to find the condition under which the phenomena occur. One use measuring instruments which are heavy bodies, not need to be very heavy, can be quite small things, but are very heavy compared with the visual atom, so heavy that we can entirely neglect the quantum. What observations can we do? The observations are only the marks on these bodies left by the interaction of the atomic objects, like the spot which can be developed on a photographic plate after the impact of an electron. Now, so far, we describe everything in the ordinary manner. But how to analyze this phenomenon? There one finds that in this field, where the quantum action is essential for the phenomena, then the interaction between the measuring instrument and the object plays an essential part. And the point is that this part cannot be separated from the phenomenon. It's not in any way possible to control it separately, just due to the facts that we have to describe, count for the measuring instruments with neglect of the quantum. It shall serve as measuring instruments, and thereby we cannot. But now, that means that we cannot. We have lost the basis for the deterministic description. The deterministic description in Newtonian mechanics entirely rests on the combination of coordination in space and time of the objects, every part of them, and the application of such laws as conservation of energy and momentum, which allow us to, so to say, bind the single links in the chains of events together. But now, in a phenomenon in quantum mechanics, when we have any information, or any unambiguous information about atomic objects, expressed in location, in space, and at a certain time, it means that we refer to an experiment in which there will be an exchange of inertial momentum between the measuring instruments like the Rickett scale we use or synchronized clocks and the atomic objects, an exchange which in principle cannot be controlled. It means that in other phenomena where we make use, we make for many other properties of atoms extensive use of conservation of inertial momentum. Such phenomena, they will announce on the detailed description in space and time. And that is just the essence, perhaps, of the lesson. That we have seen that two kind of concepts which equally important in description of experience, which in the classical theory was thought to be possible unrestrictedly to combine, then here they cannot be in that way combined. And if we, in this field, have phenomena observed under different experimental conditions and described by different physical concepts, they cannot be combined in a simple picture. If we try, we will even get apparently contradictions. But such phenomena we call complementary to each other, in that sense that each of them offer unambiguous information about the atomic objects. Together, they exhaust the knowledge about such objects which at all can be defined in human words, concepts. Now, the lesson is, we take it more philosophical, is this, that we have learned that we, in this simple field, that we have to pay attention to the conditions under which experience is obtained and the conditions under which the word we use can be well defined, to an extent which went far further than anything one had thought in physical science. But the general human lesson is that in many other fields of human interest, we meet with situations where similar caution, attention is necessary. And that is not entirely new thing, but just because we in such a simple field, so far removed from the aspect of life where we have play field of human aspirations and passion, we have got this lesson. It may be helpful in to speak in other fields. I should like to say a few words first about the old question of the position of living organisms among the other physical objects. At the time of the great triumph of classical mechanics, one compared often organisms with machines, and for certain good purposes, although it could not be a complete description. Today we know that to account for the properties in living organisms, we have to take essential recourse to what we've learned in atomic physics, in quantum physics. It is quite clear that the very complicated molecular structures in the cells which are responsible for the hereditary properties of the species would be quite impossible to understand their stability on the ideas of classical mechanics, but just in quantum mechanics we have learned that that is possible. Next, I want to use just one simple example more, that the laws for the production of mutations, the empirical laws, by the influence of penetrating radiation, they follow the same laws which we study in atomic physics of reactions between radiations and atoms and molecules, but which have quite different aspects than what could be expected from classical physics. Now, this in biology, a very great progress is taking part, where one make use of these advances, and we may call that all a mechanistic approach, because also quantum physics, quantum mechanics is a rational generalization of classical mechanics, and this approach contains very great promises and probably will have no limitations. But the question is, how does it stand with the old problem of called explanation of life? And here we must first of all realize that life is not a word which finds any application in physics. We have no reason to describe the phenomenon we there have to do with the life, and exactly the same in atomic physics. Life is, so to say, an element in biology, like the quantum of action is an element now in physical science. At any rate, for the quantum of action, the whole point is that no explanation can possibly be given for it on the basis of classical physical ideas. Now, what do biologists use the word life to? Is to remind about such properties of living organisms as their cell regulation, as their adaptability to environments, and so on. Now, the point is, which lying near from the lesson in atomic physics, that to see that such different approaches, which one may call mechanistic or finalistic approaches, they are in no way contradictory to each other. They are rather expression for complementary situations of observation, where we either try to study details or we think of the organism as a whole. I would like to say it's not a meaning by such utterances that physicists can directly be of help to developing biology. But the point is to point to an attitude which, if you allow me to take it humorous, which I think may contribute to a better understanding among various groups of priority when one just think of how actually the words are used. But now this is meant all as a very modest remark. But I would like to go on to something very different from physics, the way we, so to say, describe what we call the state of our mind, what we call psychical or psychological conscious experiences. Now, here we have developed very rich vocabulary by which we are able to communicate important information to each other. It is important if a man tries to say that he is very dissatisfied and angry, or whether he is satisfied, content. Now, all such words as thoughts, sentiments, and whether volition, conscious, hope, and so on, they do not, of course, refer to any physical pictures. They also do not refer to some chain of events which can be connected in a similar manner as one thought in the classical physics. They point rather to situations which exclude one another and point to use of complementary use of words which one has done since the beginning of civilization. To take an example, one would say the situations where we describe, as we say, we have a feeling of volition, or a situation where we ponder on the motives of our actions. They can be at the same time. We will also describe in that way that there is a different content of different conscious content. We pay attention to a different object and different separation from the background from which we, so to say, judge it and which we loosely call ourselves. I should like just to, here it's also not a meaning, and all we're going to say, to speak with any kind of psychological scholarship, but just to point how the lesson we have learned may be helpful. But in order to describe the situation a little more clear, I would like to recount a humoristic tale, Danish literature, which is very beloved in our country. It is a tale called The Adventures of a Danish Student. This student has a very open mind, is also open to start all kinds of adventures, but is quite a lovable character. He has two cousins. The one is very practical, is what one might call dry, and the other is very philosophical. Now, the later ones in the tale find himself in an inn. He makes all kinds of troubles for himself and demands very much forbearance of the kind proprietor of the inn. And then the practical cousin come and visit him, and then speak about how his position is completely deteriorated, and the practical cousin explained to him that it's absolutely necessary to do something, and he must, as we might call here in America, look for a job. And everything is arranged for him. It's arranged that he the next day go to a neighboring mansion, get a position as teacher for children, and everything is arranged and then consented to. But then, after some weeks, the practical Christian come back and find that things has got worse and worse, and absolutely nothing is done. Then other Christian said, very sorry, but impossible, I got confusion among my different selves. You can so easily speak about me, but I, there's a term, think of that self who controls me. But as soon as I say that, I'm equally aware that there's another self who controls or think of that self who controls what you call me. And if I start on that, it gets worse and worse. And if I try anyway to get order in it, I get such a terrible headache and have to give everything up. Now, of course, the whole thing is meant just in a way that poet does, to try to describe something very general by the different aspects of any human being. It is a situation. And I hope I have made it clear, but very beautifully expressed, of the situation in which we all are, which every healthy child has the possibility to live a normal life. But of course, in case of disease, as psychiatrists so well know, it runs the risk of the splitting of the personality. But now, just by these words, I would just like to have a few words about the old discussion of the freedom of the will. Here, it's not a mean to refer to any physics. It's just, after development, it is just quite impossible to affirm such things as been done through the ages to problems of determinism and so on. But it is just clear, when one speaks quite simple, that the word will, like other words, are quite necessary to describe the richness of conscious life. Now, also, what we use it for is in some way connection with that we have a feeling that we have the possibility, so to say, to make the best out of things. Speaking very loosely, it's a simple problem, of course. It is not possible to say whether we have the feeling that we want to do something because we have the feeling that we can, or that we only can because we will. But the problem is just to see that we use the words free will in describing our situation, just in as clear manner that any other words, like responsibility, hope, which all are words which cannot be used or defined in any unambiguous way except on the basis of the situation in which they are used. Now, I might go still further for a moment, go into saying a few words about what we call ethical values. Now, that is a word which is very far from physics, or equally far from quantum physics. And it's a kind of words which even, it's difficult in philosophy, one might say, philosophical schools, and sometimes say it, not for cynicism, but for cause and honesty, that we must avoid evaluation. But that is simpler said and done, because if there should be, I don't think they exist, but if there should be a philosophical school to say we must avoid the use good and bad, I think they would be tempted to say that it's good philosophy to do so. So that is just is not so easy to avoid appreciation. But let us just for a moment go right into it and ask, how are such words as justice and charity actually used? Then, first of all, they are necessary in speaking of connection, human connections. All stable society has demand individuals for fair play, and they get met, incorporated in judicial rules, and become the law of the land, as in this country Oliver Wendell Holmes has so wonderfully explained, clarified in his book on the common law. On the other hand, human life would be deprived, not of much, but almost of all richness, if we could not speak of sympathy, friendship, love, and so on. Now, it is clear that in all cultures one tries to combine these two things, justice and charity, to the utmost extent. But on the other hand, we must also make us clear that in a situation where there is clear basis for unambiguous use of the word justice, of judicial rules, in that situation the word charity finds no place whatsoever. But equally, force has been emphasized by great poets and wise men that compassion and goodwill can bring any of us in conflict with all ideas of justice. Now the point I try just to emphasize is that here we have two words which can be to a very large extent combined, as we saw that space-time description and conservation laws can be combined in classical physics. But for this finer, very varied regularities of nature, we have a situation where they must be used in a complementary manner. And the word charity and justice, on my mind, actually apply in order really to express the richness and what we mean by emphasizing human values. They are used in a complementary manner. It's not a question of taking one for the other, but they are used. Now, in order to emphasize what the point is, it is just this, that what we learned in physics was that we got a situation where we could not neglect the interaction between the measuring instrument and the object. Psychology, we just see a quite similar situation as a shifting of the separation line between subject and object. And here in social problems we have to do with the relationship between the individual and the community to which it belongs. Relationship which is of a very rich, many-sided kind, and where the actual different words correspond to different situations. Now, I'm afraid I've already spoken very long, but I should like, for end, to say a few words about the comparison between human cultures. I'm not thinking directly on kind of difficulties we have in the world today which we surely must hope can be overcome. But I'm thinking of that kind of experience as ethnographers have on expeditions to peoples who have lived for a long time in comparative isolation, like on one of the beautiful islands in the Great Ocean. Now, what one finds, what one knows, is traditions and customs very different from what we are used to. So different that it just appears as a great surprise that under such conditions there can, at any rate, so slow or fine, can exist a certain harmony within the culture. Now, one will see how shall we compare such cultures. And also, I suppose, all have heard, one sometimes with certain effect, compare different human cultures, let us say, with the different ways in which observers coordinate, describe, different observers described physical phenomena. Has been made so clear by the theory of relativity. But there is this very great and fundamental difference, that the actual use of the theory of relativity, the point by which Einstein succeeded to give physical science such a unity and to discover new physical laws common for all observers, is this, that how different observers may describe experience, any of them can foresee how the other observers will find it for them proper to coordinate experience. But if we compare human cultures, the situation is different, because every culture contains an element of complacency, not meant as a criticism, but meant something quite analogous to the instinct of self-preservation in any living organism. Now, therefore, it is surely very difficult, not impossible, to appreciate traditions of one culture on the basis of traditions of others. And in that sense, there is that mutual exclusion in them that one sometimes has said that these cultures are complementary to each other. But there is that very great difference between that logical, necessary exclusion, use of concepts, which we have atomic physics, which we have in psychology, because the cultures, they are only have that mutual exclusion as long as they are isolated. And by intercourse, they first of all develop themselves, and next by intercourse, they can be changed. Cultures can conflux, as we know so well from history, and progress may in that way be obtained. Now, I want to just to say just a few words about how important today it is to promote intercourse between nations. We must understand that the situation in which the progress of science has brought us with these very great new promises for promotion of human welfare, and at the same time the dangers which the increase of our mastery of the force of nature bring with it. The situation is similar as with all increase of knowledge and abilities, that such is always connected with a greater responsibility. At present, we have a situation which constitutes the most forceful challenge to civilization. The hopes are quite unique in some way, because quite apart from all present difficulties, we must really reckon that there can not be a new great war without human suicide. So in some way we have greater promises today for a peaceful future, and we think about how through a long history of human civilization every conflict has so far been settled by our might. Now just the problem is how to go about it. That of course is very, very difficult to say. But a little point I want first to mention is that it is a new situation to mankind, and certainly demands a new approach. Just like we in science, when one meet new problems, it has been necessary time after time to modify our viewpoints and approach. And here nobody of us underrate the difficulties. But the question is, what resources do we have? And I would just like to say that the resources, and therefore the responsibility, should be the greatest in the countries like your great country, others where through happy development there is so large a freedom for the individual, where it is so much simpler to speak openly between everyone about all possible procedures than countries where unhappily such freedom does not exist in temporary, we hope, epochs of dictatorships. And the point I only wanted to say is that it ought to be the best omen for the future that we actually are dealing with the results of a development which arose of pure scientific endeavors with the sole aim of augment our knowledge and understanding of that nature of which we are part. But just like this was very essential promoted by such close international cooperation, it points to the importance of any rate in signs of the closest possible international cooperation. I hope I've made much of a said is may sound very superficial, and much of I said in this lecture, but it touches upon points which does, we hope, modestly will help to the understanding by pointing to something which is quite common to all humans. And I think, however difficult problems is at the moment, that the good, where every nation can only manifest itself by the help it can offer others, by what it can contribute to common human culture, may be nearer today than it has ever been in the history of mankind. I want to thank you all for patience that you have listened to this long talk, and I want again to say how great an honor and pleasure it has been to me to speak at this University of Oklahoma, where that the question of the education of the younger generation is considered so serious, and where education nowadays will mean not only education to good citizenship in the great country, but education to the service of the great cause of all mankind.